Hi everyone. So today we're going to be having a lesson on trigonometry, an introduction to trigonometry. And I know that it's going to be a little bit longer already, so just please bear with me today. If you need to pause, press pause, take a break, walk away. But before we get started, I want to talk to you about a triangle and how we label things and where the parts are. If we have a right triangle, which is the kind of triangles we're going to be talking about, let's go ahead and draw a small triangle in maybe the top right corner of your note packet. And we're going to call it ABC. Now, anytime we're talking about something in trig, we're going to be talking about a reference angle. A reference angle is one of the two acute angles in the triangle. So A and B would be reference angles. The right angle is never going to be what we refer to in the program, in the triangle when we're dealing with trig. But let's look at B. If B is the reference angle, then we need to know where its opposite side would be. So the opposite side of B would be directly across from it. So we refer to that as the opposite side of the reference angle. And then we also need to know what the adjacent side would be, or the adjacent leg. Well, I know you'd love it for it to be the hypotenuse, but we're talking about opposite and adjacent. We're talking about the legs. So the adjacent leg would be the one right here on the bottom. So this would be the adjacent leg. So we have the opposite leg, we have the adjacent leg. And then we know that the side opposite the right angle is always the hypotenuse. I'm going to be referring to those sides a lot, okay? Another thing that we need to understand in trigonometry is that if the angle is a capital A, then the side opposite would be a small case a, and that would be referring to the side. So in this case, CB, we would refer to it as A. B, capital B, across from it, we might use the small case b, and the hypotenuse would be C. Now, we've used those letters a lot, but you'll see other ones used as well, but they'll be lowercase if they're referring to the segment. All right, now we're ready to talk trig. Okay, so what in the world is trigonometry? Well, in its most basic terms, we know that if we looked at this word and this word, trigon, well, gon you've seen in polygon, which means angles, and tri means three, so it's a triangle. Okay, and metry is another word for measure. So trigonometry relates to measuring triangles. Now, I like to think of it as like all things possible in a triangle, okay? And also, when we're talking about trigonometry, because we've dealt with triangles, why do we need this whole its own math, area to talk about triangles? Well, because trigonometry actually refers to things that are periodic, functions that are periodic. That means they happen in cycles. So, like the waves in the ocean, they are periodic. They go like this. They keep going. The days of the year, right? The days of the week, they keep repeating. We start at Monday, and then we go 7 days, and then we repeat. It's a period, okay? That's a period. When you ride your bike, the circle of your bike is going around and around and repeating. So those are cycles, and so that's why we have this need for trigonometry. All right, so I'd like you to go ahead and draw in this triangle, this sets of triangles I gave you. I'd like you to put in a 30-degree angle right there. And I'd like you to label this side 2, this side 4, and this side 8. Now, I'm hoping you recognize that these are similar triangles. We've got triangle ABG, triangle ACF, and triangle ADE. All right, so they're also 30, 60, 90 triangles. 30, 60, this would be 60, this would be 60. So you may notice that all the angles are exactly the same. And because they're similar, well, first of all, this then would be this would be 4, sorry, it would be 4. FA would be 8, and EF would be 16. All right, so if I asked you to find the ratio of that reference angle of the opposite over the hypotenuse, we would say the sine of A, that's one of the ratios. Actually, let me take a step back. If I asked you for the ratio of the side lengths of the opposite of A over the hypotenuse, you'd say 2/4. Or you possibly could say 4/8. Or you could even say 8/16. So you might notice the angle didn't change. Angle A did not change, but the side lengths, their ratios did. But if I simplify them, the ratios are all the same. Well, that angle, that 30-degree angle, actually relates to the lengths of the sides. And we have 3 trig ratios, trigonometric ratios, that allow us to calculate either the angle or the side lengths if we have one or both. Those 3 ratios are the sine, cosine, and tangent ratios. We actually kind of make them shorter by saying sine, cosine, and tangent. And if we're using any of these, we would be asking you for the sine of an angle. So in this case, our reference angle is A. So sine of A, cosine of A, and tangent of A. So these are our 3 ratios, and I'm going to talk to you more about them, okay? All right. Let me move on to the next page so I can key you in on those 3 ratios. All right. So sine, cosine, and tangent ratios are used to represent the side lengths in a right triangle. And again, they're ratios, so you have to remember that we can represent ratios as fractions or decimals. Okay? So first of all, let's go ahead and label. We have this right triangle. Across from B, we have a lowercase b, we have a lowercase a, and we have a lowercase c. These 3 ratios relate to those sides, whether they're the opposite, the hypotenuse. So the sine of the angle, so if I said to you the sine of A, the sine is equal to the opposite side over the hypotenuse. The opposite leg over the hypotenuse. The cosine of A is equal to the adjacent, its ratio is the adjacent leg over the hypotenuse. And the tangent of A is equal to the opposite leg over the adjacent leg. Those are actually the ratios. All right, we have this really fun mnemonic that we can use to help us remember that. SOHCAHTOA. SOHCAHTOA. Look at that mnemonic. So, how does that relate to this? And ka, how does that relate to this? And tangent, how does that relate to this? Well, the sine of the angle is equal to the opposite over the hypotenuse. The cosine of the angle is equal to the adjacent over the hypotenuse. And the tangent of the angle is equal to the opposite over the adjacent. Okay, so we are going to have to know those ratios. I'm really hoping that this mnemonic will help you remember the ratios. SOHCAHTOA. I always write it on the top of my paper anyway. Okay. All right, so let's try an example. So it says use the right triangle. Oops, sorry. I already did that. Sorry. Find the sine of angle R, the cosine of angle R, and the tangent of angle R. Well, we don't have a triangle, so I want you guys to draw one, and I want you to put in a right triangle. And I want you to label that side 1 and that side 3. And we're going to label this angle right here R. So that's our reference angle, okay? All right. The first thing that we have to do when we deal with a triangle is if we're given 2 sides, we have to use the Pythagorean theorem to find the third side. So I'm going to do that. So I'm going to do 1 squared plus, we'll call this x, plus x squared equals 3 squared. So 1 plus x squared equals 9. We're going to subtract 1, giving us x squared equals 8. And so x equals root 8. Actually, x equals plus or minus root 8, but remember, since we're talking about a triangle, we're only looking at the positive value. So this is root 8. So I'm going to put it in there. All right, so if I want the sine of R, I'm going to show you 2 ways, using a fraction and a decimal, okay? So fractions, the ratio as a fraction, the ratio as a decimal. All right, so if I want the sine ratio, the sine is equal to the opposite. So the sine of the angle is the opposite over the hypotenuse. The cosine of the angle is the adjacent over the hypotenuse. And the tangent is equal to the opposite over the adjacent. All right, so sine of r is equal to opposite 1, hypotenuse 3. The cosine of r is equal to root 8 over 3. The tangent of r is equal to 1 over root 8. Oops! Houston, we have a problem. We have a radical in the denominator, so we need to fix that. How do we fix that? We rationalize the denominator. Remember, rationalize the denominator. We multiply by root 8 over root 8. That's going to make, root 8 times root 8 is going to make the bottom rational. So we have tan of r is equal to root 8 over the whole number 8. All right, so those are these trig ratios as fractions. I can grab my calculator and write the sine of r is equal to 0.3 repeating. We'd really write it as 0.3, okay? All right, we could say cosine of r, if I put root 8 over 3 in my calculator, I'm going to get 0.943. If I put root 8 over 8 in my calculator, I'm going to get 0.34. Okay. Now, there are a couple things to note. One thing I want you to think about. The ratios for sine and tangent, sine and cosine, can never be greater than 1. They can never be greater than 1. Now I want you to think about why that is. We're going to talk about it in class tomorrow, okay? All right, so let's try one more. Here we've got, it says given the triangle, it's a right triangle, so let's go make sure that right angle's in there. Given the triangle, find the sine, cosine, and tangent of angle A and angle B. Actually, we're just going to do angle A. Okay, so we're going to do the sine, cosine, and tangent of angle A. So here's angle A. Well, I need the hypotenuse, so I look to see if it's a Pythagorean triple. It's not, so it means I got to use the Pythagorean theorem. So 2 squared plus 7 squared equals x squared. We get 4 plus 49 equals x squared. So 53 equals x squared. And now I'm going to take the square root of both sides, knowing that's giving me a plus or minus answer, but we're going to look at the positive. And root 53 does not simplify. Okay, so now we go through our ratios. The sine of A. All right, sine is opposite over hypotenuse, so that would give me 2 over root 53. Yeah, I'd have to rationalize that. So root 53 over, I'd multiply by root 53 over root 53, giving me 2 root 53 over 53. Okay, I could also turn that into a decimal if I wanted to. All right, the cosine of A. The cosine of A is equal to 7, adjacent over the hypotenuse. So 7 over root 53. I have to rationalize. So that's going to give me 7 root 53 over 53. And then the tangent of A, so the tangent of the angle would be the opposite over the adjacent, so 2 over 7. All right, so that's how I can find the ratios of side lengths. Notice I didn't find the angles, okay? But how can I find the angles using these ratios? Finding the angles is actually different than finding the ratio, and we want to make sure we understand that. If I want to find the angles, I actually have to use the inverse function, okay? So I have to use the inverse function. Now, I want you to grab your calculators because you're going to need them. Where'd mine go? Oh, it disappeared. I had it open. I must have closed it. So when we want to find the angles, the function, sine is the function. Its inverse is going to be called the inverse of sine. Give that a second. Thank you. All right, so the inverse notation that you guys actually probably may not have ever learned is a function. So if I wanted the inverse of sine, I'm going to be using the -1 feature on my calculator. It actually doesn't mean -1, it means inverse. So we're going to be using that feature. So let me show you what I mean. All right, so first of all, when you're in your calculator, I want you to go to the mode, okay? So the mode can be found right here on the calculator, and you want to make sure in line 4 that it says degree, that degree is highlighted. Mine is not, so I'm going to move down to there and move from radian to degrees and press enter. Okay, then I'm going to quit to clear my screen. Okay, so I want to get, we're going to say this, the tangent of 2/7, okay? So let's do the tangent of 2/7. So I want tan. This is how I'm going to put this into my calculator. Inverse tan of 2/7. So I'm going to go to my calculator. I'm going to press the second button and then tangent. And then I'm going to put in 2 divided by 7. And that's going to give me 15.9 degrees. So the tangent of angle A is, what did we say? 15.9 degrees. So A is 15.9 degrees. Now, that's the only time I actually have to use the inverse my calculator, because I can find B by doing 90 minus 15.9, which is going to give me, so 90 minus 15.9 gives me 74.1. So angle B would be 74.1. All right, guys, there is a little trick or mnemonic I use to help me. When I need the angle, I need to use the inverse, NAUI. It's actually a certification when you go diving to get certified to dive, NAUI. Need angle, use inverse. Need angle, use inverse. Need angle, use inverse. Okay. All right, one more thing. I want to show you what you can do. So we're going to skip that next example. We're going to go on to this example. Is there a way for me to find the length given only an angle and a side? Okay, so here I have this triangle. This is 24 degrees, so put the degree symbol if it's not there already. And I see it's right, and I have an X, I have an angle, and I have a side. As long as you have an angle and a side or 2 sides, you can find missing pieces in this triangle. So the first thing I do is that angle that I have, I call it the reference angle, okay? The reference angle. Because we're going to refer that angle to the sides we have. I look at the reference angle and I say, okay, what do I have and what do I want? Well, I have the adjacent and I want the opposite. So in reference to 24, I have opposite and adjacent. So in my SOHCAHTOA, my opposite and my adjacent is tangent. So I can write an equation to solve for x. That equation would be tangent, so tan 24, so it's tan of the angle equals x over 20. Okay, now here's the funny part. We have to solve a trig equation. This isn't like anything you've ever seen. You've never had equations with words in them before. So what we need to do is we need to multiply both sides by 20 to clear the fractions. Okay, so we're going to multiply both sides by 20. Now when we do that, we're always going to want to put that 20 in front of the tangent. So 20 tan 24. On this side, the 20s will cancel, so we get x. Now we're going to grab our calculator, and on our calculator, we're going to put in 20. I don't need the inverse because I'm not finding the angle. I have the angle. So 20 tan 24, and we press enter, and we get 8.9. So x is equal to 8.9. I can find the other angle by finding its complement, and I can find the third side by using the Pythagorean theorem. All right, guys, I know this was really long, so I'm going to stop there, okay? I'm going to stop there, but I do want you to do the try now right below it, okay? And that is 56 degrees, and that triangle, if it's not noted, is a right angle. So 56, and this is a right angle. All right, I'll see you later. Have a great day.